Hello everyone. Welcome to the second roll call breakout call. Today the idea is to talk a little about fee markets and specifically, of course, the on the layer two side, the concentration, what might change in the future, what should ideally change, and how we could do that. I thought for structure it might be good. I prepared just yesterday evening like a little 1 minute, 2 minute kind of brainstorming presentation, just kind of my thoughts, the way I structure kind of how I think about it. And maybe I start with that and then we go into like a quick round and have the different teams that are on the call kind of present, not present, of course, just briefly kind of mention how they think about it, if that sounds good. So I'll briefly share my screen if I am able to do that. Let's see. Does anyone see my screen?
Yes.
Awesome.
Yes.
Okay, sure. Yeah, again, as I was saying, like super quick. So basically, the idea is the way I kind of thought it might be a good idea to structure this would be to kind of like have it separated into three topics. So one of them is just taking the EVM with EVM equivalents, right? That kind of the old topic comes with many kind of problems because the EVM was originally designed for layer one, the layer one context, and so just the simplest thing in terms of fee markets is just to try and kind of do some repricing. Then the question more specifically is how in the layer two context how to best charge for the portion of the fee that go to layer one settlement cost and data availability. And then the third one, that one was the last minute addition. So I don't have much thoughts on that, but the question basically just being is the kind of the model of congestion pricing that we use on L1 that resulted in EIP 1559 even the right way of approaching this in the layer two context. So basically, does 1559 make sense in the layer two context? So on the gas costs side, basically the idea is in general there might just be a somewhat different relative kind of cost or kind of maximum availability of different compute resources on layer two than on layer one, say bandwidth versus compute versus storage access, these kind of things. So how to ideally kind of price that all more appropriately. And then of course in some, like especially on the ZK side, there might be some specific operations that are just vastly more expensive. And so ideally, of course, those also want to be repriced. Challenges, of course, is that if you make vast changes about pricing, then a lot of existing contracts that people would just want to port over to your network either just don't work at all anymore because they made some assumptions about pricing, or at least they are now way inefficient because they no longer kind of they're not specifically compiled and optimized for that gas schedule. And of course, you also requires client modifications. Is there some sort of way of making this very easy in a modular way of doing these modifications? And then, of course, again, kind of if you need contracts to be specifically compiled with that in mind, how do you have language and tooling support, these kind of things? And then just to mention kind of potential solutions or things that might help with this would be, I mean, of course, one, the IIP process for standardization. If there was some specific kind of core here that many teams would find useful, then there would be maybe a way to make it more feasible to have that adopted. And then in specific, and I know we have some people from Epsilon on the call as well. So once we get to this in the open discussion section, that'll be great. There's this proposed feature called EOF, so kind of version bytecode, that one of its goals is to remove kind of gas introspection from contracts, and that way it would at least make contracts more able to run on instantiations of the EVM that have somewhat different pricing under the hood. So that was kind of topic one. Again, I'm just going to go quickly through them just to kind of have something that we can then refer back to. So the second topic, kind of L1 settlement fees. um, in a way, basically kind of thinking about it as like a very, very basic version of a two-dimensional fee market. Um, Specifically because the level of L1 fees that you charge users, right, that is completely independent of the current congestion level of the L2. And with the annoying exception of ZK rollups that actually commit to state diffs, um, you can already predict the exact kind of settlement cost, or at least kind of proportional to other transactions of a transaction, by looking at it without even executing it, which is nice. And right now, everyone, I didn't want to insult you by saying makeshift mechanisms, but right now every L2 kind of that has like their own kind of way of how to charge for that, but it's not necessarily ideal. And so ideally, you would want to have some sort of 2D solution there. Although one thing we could talk about, maybe this is just not an urgent thing. Maybe this is just fine as it is. But basically, ideally, 2D solution, standardized across layer twos. And then the big one that everyone always mentions in this context also is, oh, okay. Yeah, so the big one people always mention in that context is kind of the how hard it would be to have wallets and whatnot support a new transaction type. One idea here would be to, I mean, with ERP 4844 now we have a transaction type that has two-dimensional pricing, so we could basically copy that and just repurpose that blob pricing for the L1 fees instead. And then again, kind of the idea would be like with leveraging IP. The nice thing is if there was such a transaction type, it would be completely optional, right? So like as long as wallets want to keep using the old ones, that's perfectly fine. But then maybe over time, we could see slow adoption of that transaction type if it makes sense to introduce that. And then the last topic, just to briefly mention it, congestion pricing. So basically just the idea being that on layer one, we kind of arrived at 1559 after some years of iteration, just because it's a pretty good fit for our model of kind of congestion pricing, right? Where basically like we don't actually charge for for transactions because to reimburse, I don't know, users running full nodes. It's really purely to kind of decide who gets into the limited block space we have. On the L2 side, it's a bit more complicated. Of course, you don't have quite a fixed throughput because there's more kind of variable batch frequency. Of course, you still have some sort of congestion, sequencer approval, kind of choke points, chain growth, all these kind of things. So it's also not like it's congestion is not a factor at all. And possibly you want to kind of charge above clearing price kind of prices, or at least that could be an option. And so question is, does it maybe make sense to kind of try to unbundle 1559 and adapt it, or like only pick some of the aspects for the layer 2 context in particular? Kind of the way at least I want to I think about it is kind of 1559 is kind of the combination of these three things. Kind of the base fee oracle, the way of kind of making the revenue go to the protocol, and this kind of nice second price auction aspect for users. So there may be some subset of that we could do in the layer 2 context in a different way. So I don't know. Those were just kind of my thoughts when I was preparing for this call. Yeah, and then I guess the idea could be now. I'll stop sharing for now, and maybe we can refer back to these slides later in the open discussion. But to maybe just go through the teams that are on the call and just have you all very briefly kind of mention, is fee markets a topic you have thought about? To what extent have you thought about that in the past? What kind of maybe beyond what I mentioned just now, kind of are thoughts you have, and just kind of to get us started. So yeah, if maybe someone from the teams here could just raise their hand and then we go around. Or Ed, if you want to start.
Sure. Yeah. Hi, everybody. I'm Ed from Off-Chain Labs. We're the main developers of Arbitrum. For us, the top priority for standardization is to standardize some way of expressing the pass-through L1 cost, settlement and data availability, to have some transaction format and API calls that allow that to be expressed instead of having to force everything into a one-dimensional model. It's not clear, I think, whether the EIP 4844 format is quite a fit for that, because it seems to be assuming that what you're paying for is data per byte, and I think it's a little bit more complicated than that in pricing. One thing to consider, I think, is if we're going to be adding a dimension to gas pricing, and maybe two dimensions, one for blobs, one for pass-through data, one for, and then of course the original gas, I think we should consider going the next step and creating a standard for multidimensional gas generally. As far as the issues that Ansgar mentioned on the slides, I think several comments. First of all, for L1 fees, or the sort of pass-through fees, I think there are two key issues there, two key challenges in pricing. One is that the price per unit is determined by someone else, by the L1 or by the foreign DA service, and not decided by us. So it's a different kind of problem. It's more a cost accounting problem than it is a price setting problem. And second, we can't in fact predict the exact settlement cost of a transaction, the exact pass-through cost that it will impose, for two reasons. One is compression, because this transaction will be batched and compressed together with data that we haven't seen yet. And second, because of time delay, that the transaction will be posted onto L1 for data availability, but that won't happen until a bit later. And so the relevant L1 price is not the current L1 price, but whatever the L1 price is going to be when it gets posted, which we don't exactly know. So I think there are some different issues there. And so I think these sort of pass-through costs are fundamentally a different beast than other forms of gas. In terms of congestion pricing, I think we see that the problem on L2 as closer to the L1 problem, perhaps than maybe some others do. And the mechanism that we currently use is pretty close to 1559. The main difference is there's a minimum base fee that is designed to ensure that costs can be covered. But it's an active research problem, and we're doing active research and maybe innovating in the future in this area, how exactly to set the primary gas fees in a way that that better meets the sort of mutual goals of the chain. But we think that the problem of congestion pricing for L2s is pretty closely aligned with the congestion pricing problem for L1s. As far as repricing of instructions, we put a lot of value on being compatible in terms of the number of gas units used by each operation with Ethereum. And so we would expect to continue to move together with Ethereum on that issue. That's it.
Thank you, Ed. That was very helpful. Peter, you want to go next?
Yeah, sure. Hey, this is Peter from Scroll. Just to reflect on Ansgar's slides. So in our case in Scroll, we do have this new dimensional fee for the settlement fees called the L1 data fee. And yeah, this is quite similar to Optimism. From what I know, I think Arbitrum is a different mechanism, so it might be hard to standardize it, but I agree there's value in standardizing the mechanism here for tooling support. And I also wanted to mention the issue of compression that Ed already mentioned, that we cannot exactly predict what is the contribution of the data cost of each transaction, but I think even with compression, some heuristics work fairly well here. Apart from this, I think a multidimensional fee market could also be interesting to be used for proving fees, so that we can directly charge for the proving costs for each transaction. So we're very excited in exploring that in the future.
Great. Thanks for that. Do we have any other teams on the call? Maybe if you're on the call from a team, but you're maybe not the fee market expert or something, could be still be interesting if you want to briefly say, hey, we've maybe thought about this a lot, or not yet so much. I don't know the details, but you know, something on that, if anyone is.
Hello, my name is Carlos. I'm from Polygon's EKVM team. Okay, basically, first I want to explain a little bit what we do. Is we introduce kind of a new field in the transaction, which is not signed, is selected by the sequencer, and it is called the effective gas price. And Basically, what we could do is to just reduce the gas price that we charge to the user in order to charge a fair gas price, which includes the layer one data availability cost and the layer two, the standard Ethereum gas, I would say. Then I think that one challenge that we have ahead of us is how to price the zero knowledge resources that a transaction consumes. We have defined kind of 6 GK resources in our case. And I think, for example, these resources are the key state machine, binary state machine, arithmetic state machine, steps, and so on. And here, one of the difficulties that I see is how to standardize these GK resources between different projects, since we have different, let's say, proving systems. I mean, it's not clear and not an easy path in order to do that. That's basically my thoughts.
Great, thanks. Yeah, it really seems that there's some specific issues on the ZK side that are especially kind of interesting as well. Do we have any other teams? Anyone else?
Yeah, hi. My name's Elias. I work with the Kakarot at KVM. Yeah, we've just started to think about the fee markets. As you may know, may not know, we Kakarot at KVM relies on the Starknet OS, so the underlying Starknet client, and currently Starknet uses first in first out, so no fee market, but we are actively looking into it, especially because we've chosen to kind of go the no repricing route, kind of what I believe Ed said for Arbitrum, which is even though for us under the hood, Ketchak is not priced the same way as the L1, we still use the L1 price for lack of better solution for now. So there is a disconnect in this. There's also a disconnect in congestion. So I think we're very interested in multidimensional gas. But yeah, we're just getting started in understanding the ins and outs and the challenges of pricing correctly. So for now, everything is included one-dimensionally in the gas price, the L1 data availability, the shared prover costs, and the KROVM steps that emulating the EVM incurs. So it's a bit raw, but it works. But yeah, that's it. Thanks.
Thank you. Anyone else? Okay, looks like that might have been. Oh,
Hi,
sorry.
this is Andreas Freund from I'm co-chair of the Layer 2 standardization working group in the EA Oasis community projects. And we've been working with Off-Chain Labs and ZK Sync, Metis, Optimism, also Linea, and a few others on a transaction fee specification, not at the technical sort of interface level, but at the level of actually how you define all the different terms and what are the requirements around the fee structure, so multiple fee components, and we are and we just published a draft, and we're calling out sort of the challenges, especially around the data fee for posting to L1. So they're just simple requirements that towards the end user, developers, etc., that when you're displaying a fee must be met. So I think that's a first step. But from a technical point of view, I think there's the opportunity to think about in particular the data fee in particular, because it varies so greatly across L2s, and in order to provide a sort of like a more stable fee towards end users, is to do option pricing. So you're basically pre-buying, and then follow that up with a hedging strategy in order to smooth out pricing. So thinking of treating gas just like any other commodity you would use, in terms of like oil or gas. So, but I can post the link to the.
Yeah, I do remember kind of
in the chat.
seeing that like a couple months ago. That's a really good point. I did not know that you had just published something. Also, I'm not sure if you are in the RollCall Telegram chat, but if you are,
Yes, I am.
Would be great if you could also post the link over there as well for people who are not on the call. And I definitely agree with a lot of what you said, especially also like I think, for example, things like option basically smoothing out the cost L2s pay on for settlement. I think that's maybe probably out of scope for this call, but it's definitely something that I could imagine emerging, maybe like as a kind of extra service or layer in between, that I think would be very valuable. And I even remember when we were preparing for shipping for 844 that there was briefly a discussion: do we want to have an options market embedded natively in the protocol? We decided against it for complexity reasons. But anyway, yeah. Alexandra, I see you also have your hand up. Do you want to go next?
Yep. So yeah, Alexandre Linéa. So just to briefly sum up how we handle the fees, concretely we just apply a multiple of what it would have costed on L1, and we apply this multiplier. So on average, it would be something like 1/15. I'm not sure about the exact number. I don't have the direct knowledge of that. And depending on the variation of the cost on Ethereum, we may change that multiplier. And so that gives us a very rough way to price L1 data, but at the same time, it has the benefits of being, from a user's point of view, exactly the same thing as if you sent it on Ethereum, which I believe has some value. But we believe this will be even more rough once EIP 4844 comes out, because then we will have to accumulate for the imprecision of as we send data, but the cost of the blob, since we will send it on blobs, and the cost of sending it in a blob will be variable versus other opcodes, and this will become a less acceptable solution. So we are actively looking into what could be a valid multidimensional fee solution without compromising too much on the user experience for that.
Thanks. Oh yeah, one more. But you wanna go next? I see that you're unmuted, but I cannot hear you in case you're speaking.
Can you hear me now?
Yes, go ahead.
Okay, hi, I'm Bert with Block Native. We provide gas estimation. So I've been working on an improved pricing mechanism for blobs based off of the exponential formula. And so long story short, it considers recent deviations a lot more than the current algorithm. And so I think this will be beneficial. Well, it will be beneficial after like large spikes of usage. Then the equilibrium will return a lot faster. Maybe not an issue with blobs right away, but with 1559, like the really large spikes, it takes, an hour for the price to come down. So it's basically a proportional integral controller. Like the current blob equilibrium is an integral controller on the log space of gas prices. So it adds basically a current error and just corrects things faster. So the simulations look pretty good. I'll go ahead and post it. I'm still working on like analytical solutions, but I'll just post it on the forum and see what everybody thinks.
Sounds good. Thanks for that as well. And if you, it sounds like I'm not sure if you already have something to share. If so, you could also put it in the chat. But if you're publishing something soon, then yeah. Also, ideally, if you then put the link in the RollCall chat, that would be helpful. Okay. Do we have anyone else? I guess now we had quite a few people. Otherwise, we can give it a few seconds. Good. And then we can move to the kind of the discussion section. Let's see. Of course, might be a bit of a challenge with so many people, but let's try. Yeah, it sounded like from listening to all these summaries that probably the L1 pass-through is the one where we'll have the most kind of to talk about. Maybe we still kind of stick to the order in the agenda. So that would mean that we first talk about just general repricing. It sounded like a lot of people here, a lot of teams were basically saying that they were pretty committed to not deviating from L1 pricing at all. I think that seems like a very pragmatic choice on the optimistic side. On the ZK side, of course, that is very costly because then now you have to kind of artificially subsidize the cat check and these kind of things. Yeah, I don't know how to kind of start the conversation. Maybe for ZK teams, to what extent do you think it's going to be sustainable to basically stay on the L1 pricing schedule forever and just subsidize these things, or versus to what extent do you basically feel some sort of pressure to try and move to a world where it's easier to reprice things versus L1 EVM?
Yeah, I'm the only one. Yeah, so far we adopted this approach because it allows you to use the gas pricing mechanism of Ethereum. The question for now does not matter too much because in the way linear work currently is we have a limit in the number of blocks that in the number of Keccak blocks that we can process at once in a block. If a transaction does more Keccak than that, then the transaction is simply not executed. And so the limit is set in such a way that it will be practical for any purposes. So in practice, it does not limit too much the number of use cases, but in the future, we would like to improve on that. But what we have is that even with this limit that is in practice never really reached, we do not have, we are not paying the most because of Keccak. I don't know if what I said was clear. But...
Yeah, that makes sense. Yeah, and it sounded like, say, I'm not quite sure who there was some other ZK team that said that maybe kind of a proper multi-dimensional kind of pricing model would be the better solution than just repricing in the existing dimension. So we can also touch on that once we get to the next topic of multi-dimensional. Stas,
Yeah.
do I say that right?
Yeah, thank you.
So yeah, I'm from ZK Sync, and yeah, so in our case, like things like Keshack, they work fine, but you know, if we were like to try to have the same opcode pricing as on EVM, then there would be definitely some problematic opcodes. And yeah, multi-dimensional pricing, I would say, is definitely the best long-term way to go. But I was just, you know, like as a random thought, thinking that maybe, and generally interested in the opinion of others about such approaches, if we charge during transaction the same way as on EVM, like the internal schedule is the same as on EVM, but at the end of the transaction, like after the main execution is over, post charging for, you know, whatever execution was too expensive. So for instance, if Ketchup was very expensive, like when compared to actual ad opcodes, maybe, and if the transaction used like 1,000 of Ketchups, then maybe at the end of the transaction, we could charge 1,000 gas more in addition to whatever was used in the main execution part. This way, inside the execution, the behavior is fully EVM equivalent. That is, all security invariants are preserved, but at the end, the user will still pay for whatever happened. So, no, yeah, sorry, never mind. Yeah, no, never mind. Understand why it won't work. Okay.
Yeah, I think we can maybe have a talk about the multi-dimensional side of this once we get to the next section. But Ed, did you want to say something?
Sure. Yeah, I just thought it would be useful to unbundle a couple of different things here. One of them is, do people charge the same number of gas units per EVM operation as the EVM? And the second is whether the price of gas is different, right? It might be that some team wants to make Ketchack require a different number of gas units, but still use one-dimensional gas pricing. Or alternatively, you could use two-dimensional gas pricing. But I think the term pricing sometimes actually is incorporating those two separate notions, gas units per operation versus gas price.
Yeah, thanks. I think that's really important to make that very clear when talking about this. So basically, yeah, in this section, I was specifically thinking about just charging a different amount of gas units for operations than L1, right? And so basically, rollups that want to do this. I mean, right now, I don't think anyone does that. I think right now, everyone literally just copies the EVM as is. That's the point of EVM equivalence. The question is there a need to change that in the future to enable all tools to change to be able to more easily do that, and maybe in a standardized way? Or is alternative, more elegant solutions like multidimensional pricing the way to go, or maybe neither of the above? Right. I see that Axic is on the call, given that kind of the Epsilon team has been working a lot on EUF, and that EUF kind of comes with kind of this removal of gas introspection, which I guess also then is important in the multidimensional context. But maybe here already, Axic, could you maybe very quickly kind of talk about that portion of EUF and give a quick kind of EUF status update?
Sure. So it's not only me on the call from Epsilon, but Andre is as well here. Maybe the quick status update is that the EUF specification is quite stable and has been for quite a while. Most of the changes going on are kind of minuscule or concentrate on one or two specific parts. But the general design is kind of stable. There was one larger discussion we had regarding the general design, but we decided against making bigger changes there. And we do have a EOF implementers call, which has been bi-weekly, but starting this week, it's weekly. And we moved the time of it to not be conflicting with the roll call. So basically, it starts after this call. And anybody is more than welcome to also participate there to learn more about the EOF on a weekly basis. The specific solution we can offer to this problem, well, Yeah, maybe because Ansgar said to give like a short intro. So EOF is a larger set of changes to the EVM, which introduces a number of different features which the EVM currently is lacking. It introduces versioning, introduces structure where code and data is separated. It introduces subroutines and a lot of basically transforms all the jumps to be static instead of dynamic. And also introduces a number of different changes to reduce introspection capabilities. The two introspection capabilities I want to highlight here is one is code introspection. In the EOF paradigm, it is not possible to inspect the code of any contract in platform, which means that in theory, code becomes upgradable because you could transform and replace account code because the code is not able to introspect itself or other contracts. In theory, this is possible. The more important piece, however, is what Ansgar mentioned, is the gas introspection. And the way we limit that is we do change all the call instructions to not take a gas argument. And we also remove the gas instruction and anything related to it. The actual gas rules remain the same because we really wanted to make this more like a step-by-step approach. And so we do still have the 63 of 64 rule, but with not having this inspectable, that could also be removed in the future. So with not having the gas argument in any of the call instructions and not being able to inspect the remaining gas and passing all the gas forward, this means that the only place to limit gas usage is at the transaction level. And we think that this would solve, most of the repricing problems because you could just change any of the pricing, and the single point where you have to make an adjustment is at the transaction execution level when the user sets the complete transaction limit. I hope, because I didn't have any slides here, I hope this on a high level made some kind of a sense. But lastly, we're also launching a EOF website, which would explain this in much more detail, which can be, there's still updates needed, but it will be at evmobjectformat.org. And we have a combined specification explaining all these different parts of EOF, but we do have individual EIPs for the individual features. So that's like in a high level intro.
Awesome. Thanks so much, Alex. And yeah, just to give a little bit of context. So basically, this change has been proposed on mainnet for a while. It's still unfortunately not 100% certain if and when it will reach mainnet. In this context specifically, of course, it would be relevant if it also or alternatively is shipped on the L2 side. So if and we can talk about it some more on the multidimensional pricing side. If it turns out that would be really useful, it could even be that this could be a candidate to ship this via the IP process. The nice thing is that most L1 clients have already implemented support for it, or at least are close to it. So it could be something that actually could be easy to maintain even as a L2 feature, L2 only feature, something. And of course, the reason why it's relevant also, say, for multidimensional pricing is that it now allows us to change how we count for gas on an ongoing basis. So that instead of one gas counter, there could be multiple gas counters and everything, which just isn't really possible in the current EVM because you only have this one gas opcode that expects a one-dimensional answer when it asks for the count gas. Is there on the repricing side itself? I assume we'll get back to this in a few minutes on the multidimensional side, but on the repricing side itself, is there like something else that people would want to touch on? Okay, then I would say we move on to the kind of the multidimensional side. So I guess I didn't really mention the kind of general question of multidimensional pricing in my notes. So maybe we can have like two sections. First, we talk specifically about the L1 settlement data charging. And then we talk about the more general multidimensional pricing, also say for proving and these kind of things. The reason why I didn't kind of call it multidimensional also was I think Ed mentioned that as well, is that like kind of the L1 settlement is special in that it is an externally kind of determined price that you don't set yourself. So in a way, it doesn't seem to be quite a proper two-dimensional problem. It's more of like a special case of just external costs for transactions. And also it sounded like my assumptions were a little too simplistic around the fee there being predictable from the outside of a transaction because of both compression and then of course the non-data cost portion of settlement cost. So point taken on that. Yeah, I don't know how do we best get started on the conversation here. It seemed like there is definitely more of a demand on this topic for standardization. Yeah, I mean, I don't know. Maybe I'll just open it up for general discussion. And no.
Okay, I'll go first. I think there is probably stronger agreement on the need for transaction format support and API support for communicating with users and applications about the L1 fees or L1 costs. I think there's more probably alignment around that than there is alignment about the particular way that these fees would be calculated or passed through. And I think that there's less alignment about the second thing for two reasons. One is different kinds of systems have different balances of costs, right? So ZK systems have higher proving cost, for example. But also because there are differences in design approach among different rollups about how they handle this. So as an example for Arbitrum, it's very important to us that the chain almost never reorgs. And we also make it a goal that the pass-through pricing mechanism be fully trustless. Some others have different goals. Maybe they worry less about reorgs because because they're trying to prioritize something else, for example. So I think if we can standardize on formats and APIs, I think we can make progress more quickly than if we try to standardize everything.
Yes, it's a very good point. I think getting the standardization boundary right of like what to standardize and what not is very important. So it sounds like basically what you're saying is just the how to charge for it, that's the part you'd wanna so basically like the mechanics of kind of how to expose it to the user, that's what you'd want to standardize, and then how you actually come up with the fee, that's what you basically would leave up to each L2.
Yeah, exactly.
Okay, and I mean, of course, question there is whether people generally feel similarly about this, and then also, of course, I think specifically a good question is, do people agree that having a specific just transaction type for this, basically standardizing on a transaction type, would be the main area of focus for standardization here?
I think you would also want to standardize on APIs for things like gas estimation.
That's a very good point. Yes, transaction type and APIs. Carlos?
Yeah, I think that adding a new transaction type, and I'm guessing here it's just a question. It's about just adding a new field like layer 2 gas or something like that. Layer 2 max gas, allow it to charge to the user somehow, and later on, each project could have kind of a table with its own gas consumptions in layer 2. So it's a standard for all the layer 2s, but later on, each layer 2 will charge whatever they want. So basically, this could be an approach that we could follow. And I totally agree about doing an EIPs, modifying estimate gas or whatever in order to add more data or in order to return more data from the RPC view. That's for the wallets, basically.
I'm not,
Yes.
I'm not so sure about the upside of having a new transaction type, because it's nice to display to the user that like the breakdown of where the gas cost, like the gas price comes from, like whether it's passed through, whether it's, I don't know, premium, whether it's proving costs and so on. But then at the end of the day, they're going to be like all summed in the like overall gas price, and this is still what is going to be sent to the like L2 operator. I mean, there is an upside, I guess, but if the main goal is to give more data to the user, why not just modify estimate gas so that they can know the whole breakdown of their operation, rather than, I don't know, what yeah.
Yeah, I have some thoughts on this, but let's first hear from the people with the hands raised. Peter?
Yeah, I feel like we might not be on the same page on like what we are charging the user. Is it ETH directly or is it in gas units? Like in our case for the L1 data fee, we directly deduct that from the balance. So in that case, we might be okay without a new transaction format, or maybe with a new transaction type that just comes with like a maximum data fee. But for us specifically, the API standardization would be more important. So estimate data fee, that's one API, and the other one is to add the data fee to the transaction receipt. But I feel like there are some rollup projects who do not charge in ETH, but in some gas units, so that might be different then.
Yeah, that's right. Andreas?
Yes. So if you actually look at the spec that was published, so we're breaking things out into at least 3 components for now. And there's the L2 fee, so that can have different components based on the L2. So there is the opportunity to break things out further, because you have if you think about further decentralizing like a ZK EVM or anyone in sequencer improver, then you have like 2 entities that are really have costs, right? The sequencer and the prover. So if you have multiple sequencers, potentially also multiple provers, then there's really a fee competition, and it's more the key question is what are you charging the transaction sender in the end? That it's transparent and known ahead of time, like when you fill up a car at a gas station, right? You're not driving up to the gas station and going like, what am I going to pay right now? No, you look at it and you see a price, you know exactly how much you're paying for the unit of gas, right? And then it's up to the provider to ensure that that price meets their cost needs, right? So that's where this where a market is really important. Even a market within an L2, if the L2 is decentralized, right? You can have multiple markets. You can have a market within the L2, and then you have a market for the data fee, right? For the pricing for that. So I think that is you don't need a new transaction type. You just need to have an effective mechanism that allows to produce a known price to the end users for a given time period, right? And then display what are the drivers, or where does that come from? Right? Is it an oracle? Is it a fee market? Is it you know, the sequencer, you know, sticking a thumb in the air and seeing, you know, which way the wind blows.
Right.
I think it's fundamental in this space that the cost of providing L2 execution versus the cost of L1 pass-through services, those two costs fluctuate independently, right? We don't control how much the L1 is charging us for our chains or our users for those services. And so I think we do need the ability to adjust something about transaction cost to account for the fact that there is a two-dimensional cost structure. And the closest analogy to the way that the model that users are accustomed to on L1 is you use gas estimation to tell you roughly what it will cost. But gas estimation also tells you, also gives you a hint of how much spending you should authorize, right? If you want to, because the other important part of it is the user signs the transaction actually authorizing the fee being taken from them. And so if you want a scheme where you don't take fees from users unless they've authorized it, and where the cost of pass-through services can vary from transaction to transaction, then you have what's fundamentally a two-dimensional gas market. And I think having two-dimensional gas estimation and two-dimensional authorization from the user in the alternative is to really change the semantics so that, for example, different transactions that are in the same block, L2, different gas prices. And that, I think, causes other forms of challenge. For example, it destroys the notion that there is a current gas price.
Right. And just to very briefly, by the way, give some context here. So right now, basically, I'm aware of 3 different ways how L2s charge for L1 settlement costs. So that is the Arbitrum model of, and maybe correct me if this is wrong, but I think basically just adding it to the general gas consumption with like a dynamic kind of ratio that you set at the time of execution and just charging it against the same gas limit. Is that right?
Yes.
Okay, and then there's the optimism model all the OP chains, and I think some other people also use that. For example, Peter, you mentioned, I think that you do that as well on Scroll, where basically you just don't expose that to the user at all. You independently just take that out of the balance. And then there is the third model that I know Linear uses, and I might be, if I didn't misunderstand, that Polygon zkVM also does that, where basically you just you don't have an explicit separate pricing. You just basically charge a little extra and set that so that it roughly kind of accounts for what you expect to pay on L1. And so the reason why there might be an interest in actually standardizing this in the form of an explicit like extra dimension and a transaction type, and not just a way of making that like standardizing the estimation, is to make sure that this is both under the user control. So of course the trade-off right now is that, say, on the optimism side, the user just has no way of limiting of expressing any intent about this. So you have no way of limiting the cost on this side. I've done this in the past where I sent a transaction on optimism, and I was like, oh, nice, the interface tells me at most 4 cents, and then it charged me 20 cents because of the settlement cost, and that's of course not ideal. So basically having that be both under user control, and of course in Arbitrum it is under user control, but in Arbitrum it has this other kind of trade-off of now messing with this existing mechanism of the gas limit. And you kind of, in order to have both of these at the same time, you need a separate dimension. So that's kind of just the context for why there might be demand for not just having the estimation mechanism standardized, but actually do a new thing here. I would want to move on a little bit. Andres, if you have a comment on that narrow point, do you want to?
Yeah, I think that the very notion of price variability from transaction to, or of not knowing a price before you buy is I think that very fact, even though that's what it has been, I think it's just not going to fly. People want to know what they're going to what it's going to cost them, right? And that's only fair. And by the way, from a regulatory point of view, right, even though some people might not really be interested in that here, but you know, for users in the US, for example, with action that Congress is currently considering, fees must be known and published ahead of time. And you need to commit to that. You can say, oh, it's going to be a fee, but a fee is known. So saying, you know what? Sorry, we can't do that. It's just not going to fly. It's just not going to. It's just not going to work. So I think we need to fundamentally rethink the whole notion of pricing and really treat it as a commodity. And then there are known mechanisms for how to deal with that. That we don't have to reinvent the wheel for that. You can actually go to the Chicago Mercantile Exchange and probably, you know, it's like ask them to you know, put out options and just buy it, right? It's a cost, right?
Right. I would say just because I do agree with what you're saying. Basically, I think it's because just we have so many people on the call. I think it's important that we kind of try to separate the different layers of the conversation. And I think right now we're mostly talking more like the mechanics of how to do that. But then I agree when we talk more on the, say, what then ends up kind of what is the user experience, right? And then I think what you're saying very much, like I would subscribe to that. So basically, yeah, the kind of the predictability and everything. On the kind of the more pricing mechanics, I would be curious if we kind of continue on that path of exploring a transaction type and figuring out how to best make that work. Do people generally think that, I understand not everyone thinks that there's necessarily a need for it, but people generally think this is a reasonable approach of going about it. The nice thing, of course, is that it's forward compatible. Like if a wallet doesn't immediately adopt it, even though I do think that people are maybe a little kind of have a bit PTSD from everyone on this call probably experienced that, of trying to have a new feature and then because it's just one layer 2 shipping the feature and a lot of tooling wallets not interested in supporting it. I think hopefully this will change a lot with these kind of common core of standardized RIP features where as a wallet, I now have a lot of interest in supporting this as soon as possible. But even if not, right, the nice thing with the transaction type is you can always send the old transaction type. And we've seen it with 1559 as well on mainnet that that's fine. And so it's an opt-in kind of transition. Is there any specific concerns that people would have with the new transaction type or challenges of that rollout? And then as a second question, also, Ed, I think initially you mentioned that you think that, say, the 484 approach of basically, because it's just treating data, like it would, or the 424 transaction type repurposing that might not be an ideal fit because it just could only account for data. Maybe if you could also elaborate on that a little bit.
Let me say a little bit about that, right? So it's kind of implicit in the way that 4844 transactions are expressed and priced that you're paying for all of the data in the blob. The data, it comes in units of blobs and you're paying for the whole blob because the size of the blob is not in the, first of all, the blob data is not in the transaction, but also the size of the blob is not in the transaction. So I think you would need to, whereas of course we want to be able to charge for different sizes of data, different data footprints for different transactions. So to me, that's the main issue. That for the 4844 transaction type is just fundamentally has a built-in assumption that you're always posting a full blob, and that the cost does not depend on the contents of the blob. And I know Arbitrum and someone else mentioned it as well, that you uses heuristics to estimate the compressibility of the transaction even in advance of knowing how it will be compressed ultimately.
Right. So what I'm hearing you say basically is that and this comes back to the question of what to standardize, right? So basically we need a way of just taking a transaction and mapping it to a one-dimensional value of amount of L1 space that it will have to take up. Say that could be the data itself, the compressed data, but also maybe take into account the execution, that portion that's necessary for that. And then the question is does it make sense to even map that into a one-dimensional value? You could almost imagine, okay, but I want to separately account for the portion of the execution for settlement versus the data and everything. But of course, then if at least to the extent that we want to expose that in a transaction type, it seems very, very valuable to map that to one value. So then the question is that mapping something we would want to standardize, or just leave up to each L2? The intuition would be to leave it up to each L2, but then of course, if we don't standardize it, it's harder to then standardize the rest, say the estimation, if what it even means to have, say, one settlement gas. If the meaning of a settlement gas is up to each L2, there should at least be some sort of rough standardization where roughly each settlement gas would be, one byte of one data or something like that, right? Because if we don't standardize it at all, then kind of that field now becomes in a way almost meaningless, at least across different L2s. So what exactly to standardize on in this mapping to one dimension ? And then once we have that, I guess the rest is relatively straightforward, right? Because then you just take the limit and the max price that the user set for that dimension, you multiply, and then you charge. Or are there other complexities in that?
It seems like if you want to follow the model of the L1 gas pricing, that you would want to have a notion of what is the current price of settlement gas, and then but then the amount of the number of units of settlement gas consumed by a transaction would vary depending on the transaction itself. And maybe that is how many catch-acts it does. Maybe that is something about how large it is, or how large it's heuristically estimated to be after compression, or something like that. It seems like different rollups could have different policies for saying how many settlement gas each transaction took. But the notion that there is a current settlement gas price seems to align with how people think about L1 gas.
Right. And then we would not need some sort of 1559 mechanism, because that's an external price, right? So basically, yeah.
Yeah, that's right.
Do you think, in terms of standardization on how do you actually derive the current price? This seems also something that doesn't make sense to standardize. Say basically some sort of small portion of that to standardize, some standardized way of predicting it, or some standardized way of accessing that information, because again, I assume different layer 2s have different strategies of at the point of inclusion determining what actual level to charge at.
I guess what I would propose here is to have a standard gas estimation API. Each L2 could have its own policy for deciding how many settlement gas to charge to a particular transaction. But then you have a gas estimation API that someone can call to get, the best estimate of how many of those gas it's going to require. Right, and then you could also have the transaction format be like L1 gas, where the user can say, what is the max settlement gas price I'm willing to accept, and what is the maximum number of settlement gas units I'm willing to be charged for? Again, pretty much aligned with the model of regular L1 gas.
Right, and that makes sense. And I would say, by the way, that is mostly what I had in mind in terms of repurposing the 424 transaction type, just meaning that also comes with these two extra fields. They have different meanings, semantic meaning, of course, in the blob case. And you're right that basically we can't too closely match that semantic meaning. But I think basically just having a new transaction type that just has two extra fields for a separate dimension, that's something that we could more or less copy, or there's precedent for, at least.
Yeah, and then of course the next question is, should there be more than two? Right? Do you want a format that allows more than two types of gas? Right, based on this 0-1 infinity principle, right? That maybe it makes sense to allow more types if we're going to take this step at all.
Yeah, let's maybe first wrap up the kind of the L1 pass-through specific kind of conversation, and then and unfortunately already is only 20 minutes left on the call, but that we can then talk about. I think that the main remaining topic is the kind of the dimensions beyond that. Andres, you have your hand up?
Yeah, I think it would be the about the gas estimator. So you know, if we specify the API, what is returned could be sort of like a commitment to that price. So you can have different providers of the gas estimator that will commit to the price that the user is not going to be charged exactly that price.
Yeah, that's and actually, by the way, just to mention that, because I think when we talk about this, it's always kind of important to kind of separate the responsibilities. And I almost, in my mind, this is something where this could be in a service that L2s offer, or third parties offer on top of L2s, basically just like committing, like giving fixed commitments to future prices. Which I think I totally agree with you that it's super important for UX, but I think it's not yet necessarily clear which layer of the stack that responsibility would lie with.
Well, if you're operating a paymaster for meta transaction, or even just for account abstraction, the cost there, it's like, who are you promising that to? Then you introduce again, variability that is problematic in terms of promising inclusion. You should have a price where like a transaction is either guaranteed to be included, or to know that it's not going to happen, right? I think that's really important also for it's like just providers for meta transactions, right? Or the account abstraction that's not native.
Right. To because in the interest of time, just to kind of wrap this topic up so we can move to the general multidimensional. That was mostly kind of me talking with Ed here. Is there any other team that has kind of follow-up thoughts on the specific L1 pass through and the viability of doing that with the new transaction type? And I see that we have the typical fate of a 90-minute call that after 60 minutes, many people have to jump off, or had to jump off already. Okay, sure. I actually think I personally would be really interested in kind of following up on this, and maybe even kind of if we could kind of have some sort of async kind of working group follow-up, or maybe even just a collaboration with Arbitrum or with a few teams that are specifically interested in this, to kind of try and see if we can get that to an IP reasonably soon, because to me, honestly, this seems like a big win that's not that hard to get to, with of course the level of the details around what exactly to standardize, but yeah. Okay, then I do think kind of in the time left, and maybe we can briefly also talk about this kind of congestion pricing question, but I think mostly the big remaining question is about general kind of multidimensional pricing. And again, the reason why I didn't even kind of bundle that with L1 pass-through in the first place is that L1 pass-through is almost like not even a proper second dimension, even though kind of in terms of how it's exposed to the user, it would look like that. So the question kind of being, in general, like there's of course just a few inherent extra dimensions to the EVM that we would have, like if we were to restart the blockchain from scratch, of course we would try to just have inherent, we would have compute gas, and we would have kind of state access gas, and we would have bandwidth gas, and all these kind of questions. So to what extent L2s would just really want to do that kind of thing, versus just L2 specific types of extra dimensions, like on the ZK side, the proving dimension. And then kind of, yes, so I don't know, like I'd just be curious with L2s that have specific thoughts on extra dimensions for the future. unless we lost most of the people that raised those points early in the call.
I think this is something that we would be interested in exploring. And really for the same reasons that multidimensional gas could be valuable to L1, that there are good theoretical arguments that with multidimensional gas, you can, at least in some important cases, get more throughput or have lower costs with the same throughput. So it may be more efficient for users. And it may also be that L2s run up against those limits sooner than L1 because we have more throughput and are trying to push the throughput envelope more so than L1 is. So it seems like a good topic to discuss at least from where we sit.
That makes sense. And I think, unfortunately, we lost most of the people from the ZK side already. But of course, there's also the specific kind of extra circumstance of the prover. In general, like the way I've been thinking about it is basically distinguishing static versus dynamic dimensions. So static dimensions being ones that you can basically completely predict the consumption from the outside of a transaction, because those are just they're not conceptually different, but they're just in terms of implementation that they're much easier to add. Dynamic dimensions, where you basically have to now have a second gas counter running, or a third or a fourth or something while you do the execution. That's harder to do. And in terms of kind of backwards compatibility, that's now where we basically loop back to UF that we talked about earlier, where basically it is relatively hard to do that using the existing kind of EVM with existing introspection capabilities, because you have access to that gas counter, which inherently is a one-dimensional value. So something like that might require, well, might be dependent on a change like UF that would first remove that introspection. Yeah, I mean, I guess one question could be, okay, first question, do we still have anyone on the ZK side on here that might have specific thoughts on the prover dimension? It's a bit of an open-ended question, but okay. Because then I think, just pragmatically speaking, it seems if we want to kind of move forward with something, it seems, I think Ed, you briefly asked the question, should a transaction type that introduces an extra L1 pass-through dimension, should that kind of try to already be forward compatible with multiple dimensions? It seems, yeah, I don't know. I would just be curious whether people have thoughts on that. It seems maybe that adds a lot of extra complexity for something that probably only is relevant in the medium to long term.
To me, that's the main question, is how much extra complexity do you add by making it extensible? If we think that it's something we're going to want to do eventually, and it doesn't add much complexity now, then it's worth doing. But you might need to do the exercise of actually trying to specify it to know how much pain it brings in the immediate term.
Yeah, and it's a good point that it's probably worth at least doing that. I would also say that, of course, with any of these standardizations across multiple L2s, it's important that semantically then everything is identical. And so the nice thing with the L1 pass-through dimension is that it's relatively easy to scope that in a way where semantically, at least to the extent that the fields that are in the transaction have the identical meaning it's kind of this extra kind of L1 dimension and kind of gas of sorts, and then it's up to the L2s to fill that with more specific meaning. It would, with extra dimensions, then the questions becomes how do you kind of keep that as well? It would basically require the entire multidimensional pricing to then be a standardized project, which might not be a bad thing, but yeah.
But you would at least need a standardized way to express multidimensional pricing, even if you can imagine, for example, that you have like gas types which are numbered, and 0 is execution gas and 1 is settlement gas, and then there's a range reserved for sort of L1, and then there's a range that L2s can use for their own experimental purposes, something like that.
Well, I mean, if you're introducing a new transaction type, you might as well go all in and just simply replace, you know, a number by an object, right? If you're expressing that through a JSON object, for example, the fee or the price, then then every L2 can then list the price components and variability and what have you not, based on their own needs, and it's still there's an aggregate top value, and then you have the components listed, and you just need to publish the schema, and you're good.
Right, and that's probably something that we would want to get to. The question, I mean, they're specific, just pragmatic limitations in terms of how just transactions are structured today, and I think we can't go too wild, and so presumably we're kind of stuck with the very simple way of doing it. But yeah,
Well,
I think basically what.
Well, the L2s could go wild. The L2s could go wild because you can do an abstraction, right? Because they have the freedom. They can abstract out the underlying sort of like L1 compatible transaction structure, and they can wrap that into more dynamic or more flexible L2 structure that is then, you know, where you separate out sort of like what's required with regard to the execution versus the fees and the pricing. So if you're thinking it in terms of different abstraction layers, and you have a wrapper, then if we standardize that wrapper, then then the L2s have the flexibility to express their implementation specific needs much more flexibly without having to tightly couple that to the execution to the transaction execution structure that's required, which is much more closely tied to the L1.
Right, and two narrow points on this. One is just that just pragmatically speaking, I think in the past we've talked a lot about how L2s are very hesitant to move too much away from how L1 works, just because that means that now you have to just maintain kind of deviating client behavior, and so say different ways of passing a transaction object would, I think, for now be probably out of scope of what L2s would be comfortable with doing. So we kind of have to pretty narrowly follow how L1s kind of today handle transaction objects, and then also, unfortunately, of course, because the majority of the cost for L1 settlement comes specifically from just the data size of the transaction object, keeping that as thin as possible and efficient as possible really is super high priority. So I think there's a trade-off basically between kind of cost, just like settlement cost, and expressivity of the transaction object. But I mean, I think kind of coming out of this call, my main takeaway is that probably that's the one actionable item here, right? That we should just have some sort of very specific kind of follow-on effort to just work on an IIP for 2D or potentially multi-dimensional L2 transaction type, that, which I don't know, that's very encouraging to me, and I'll kind of try and make that happen afterwards. Yeah, I'm more than happy to like spend the last 5 minutes talking about kind of this question of, is 1559 the right model for layer 2s? Of course, that's a big topic for a short amount of time. Maybe just we can briefly just touch on it, just to kind of get a temperature check. Just before that, is there any remaining comments or points on this general question of L2 multidimensional pricing? Of course, the general multidimensional pricing, that's going to be a big topic. Yeah. Yeah, I never know how long to wait with these questions. But okay. Okay. See, I didn't wait long enough. Stas.
Yeah, I just wanted to say like one small thing. I'm not sure if it has been already mentioned on this call or not, but in the RIP about account abstraction, for native account abstraction transactions, there is already a field for builder fee, and if I recall correctly, in the RIP, they would said that potentially this field could be used to, for instance, for users to provide how much ETH are they willing to pay for the pub data or whatever else. So probably whatever efforts are done with regard to multidimensional fees, they should be made compatible with this RIP or added there.
Yes, that's actually a really good point. I thought about this briefly earlier in the call, but yes, that actually, given that there's the general intent to move in the medium term to a 4337 style account abstraction transaction model, of course, any of these changes would be quite short-sighted if they don't don't take into account that long-term transition and how that all fits together. I haven't really thought about it enough to to have a specific opinion on this, other than this is important to take into account. Yes, very good point. Okay, then, and if people have to leave, then of course already, please feel free to. But for those remaining for the last 5 minutes, yeah, I would be curious to just briefly talk about the general kind of 1559. There's of course something it only came to mind yesterday evening, so I haven't really thought about that much. I'd just be curious, of course, I assume that's a topic layer twos have thought about a lot, given that you all have to make these practical decisions. Yes, so I'd just be curious to hear a bit more how layer twos think about 1559 versus other types, with like congestion pricing, non-congestion pricing, unbundling potentially these different aspects of 1559.
Okay, so from an Arbitrum point of view, we use something that is similar to, but not the same as 1559, basically a version of the exponential mechanism to do congestion pricing with a minimum price. So, in a multidimensional setting, if we're thinking about resources in a multiple and limits in a multidimensional way, there may be other approaches that, and we're continuing to do research. I think we may evolve how pricing works. But the basic spirit of 1559, which is tracking use versus target and then adjusting prices to try to reach equilibrium by an exponential-like mechanism, seems in principle to be a good approach. But we don't currently and probably won't do exactly 1559.
Right. Are there any other answers? I mean, okay, now the call really has shrunk, so I assume we might not have anyone else left on the call that has opinions on 1559, or like 1559 like mechanisms for also. Right. Then it's probably not worth at this point to go into too much more, because we also are running up on time. Then yeah, always a good fun topic for a separate call at some point. But yeah, then it's probably a good ending point here. Thanks everyone for coming on, especially of course those of you that made it all the way to the end. And I think that was a productive conversation, and especially if we maybe can actually follow up on that idea of a one pass root transaction type, then we actually got somewhere. And yes, that's all from my side. Thank you all, and have a nice rest of your day. And just to mention, by the way,
Thank you.
just to briefly mention, it's still wrong on the calendar. I'm trying my hardest to fix this on the protocol calendar, but the next roll call will be in 2 weeks, not in 1 week. Then in next week, we'll have one more breakout call on the general kind of concept of standardizing precompiles across layer 2s. And then the week after, there will be another main roll call. So keep that in mind. Awesome. Bye for now.
Bye-bye.